Okay, here we have 3 equations and 3 unknown. We want to solve for x. So in this case, you can pick the first 2 equations and eliminate 1 variable, and then pick the last 2 equations and eliminate the same variable. And in this case, since we're solving for x, we don't want to eliminate x. So if I pick the first 2 equations, equation number 1 and 2, okay, if I call this equation number 1, and call this equation number 2, and call this equation number 3, I'm going to pick equation number 1, x plus y plus z is equal to 7, and then pick the equation number 2, x minus y plus 2z is equal to 7. And then here, you want to eliminate 1 variable. Looks like the coefficient of y is already opposites of each other, so I don't have to do a whole lot with this to eliminate y. I just have to add them up. I don't have to multiply any of these row by any number. So since the coefficient of y is already opposite, let's just add them up and get one equation in terms of x and z. We get 2x is equal to 1z plus 2z would be plus 3z. So that would be plus 3z is equal to 7 plus 7, 14. So I'm going to call this equation number 4. So I need to pick either equation number 1 and 2, or we did 1 and 2 already. If I pick the equation of 1 and 3 or 2 and 3 and eliminate the same y, okay? So it looks like if I pick the last 2 equations, again, the coefficient of y is opposite of each other. That would probably be best. I'm going to use a different color here, so it would be a little different from the other 2. So I'm going to pick the equation number 2 and then pick equation number 3. Again, you can pick this in any order you like, or you can make a rule of thumb, pick the first 2 and the last 2, eliminate the same variable. So in this case would be eliminating y again. I have no choice to eliminate y because I want to keep with the same variable x and z. So here I get 1x and 5x, that give me 6x, plus 2z plus 1 would be 3z, is equal to, I have 11 plus 7 would be 18. So let's call this equation number 5. So if you pick equation number 4, which is 2x plus 3z equal to 14, and pick equation number 5, which is 6x plus 3z is equal to 11. Remember, we want to solve for x, so I need to eliminate z. So the best would be to eliminate z. So it looks like the coefficient of z is the same, except if I make one opposite of each other, then we can eliminate z. So let's go ahead and multiply this top row by minus. So that would be minus 2x minus 3z minus 14, and add them up. So as you can see, z add up to 0, and then you have 6x minus 2x, that give you add up to plus 4x. Here you have 18 minus 14, they give you plus 4. If I divide both sides by 4, there I have my x. And normally you have to find for x, y, and z. If you were going to solve for z, I would have to substitute for each x 1 in either of these 2 equations, solve for z, and then if I know x and z, I can plug it back into either of these original equations and solve for the last unknown, which is y. But in this case, looks like c is the correct choice here. X is equal to 1. Here we need to simplify that, and there are some properties that we need to recall. One property that we learned, if I have a to the power of n to the power of m, that would be the same as a to the power of n times m. Another property that we could use here is if I have a to the power of n times a to the power of m, that would be a to the power of n plus m. If I have a to the power of n over a to the power of m, that's the same as a to the power of n minus m. We want to make sure that if it's negative, if you have a to the power of negative n, you want to make it positive as 1 over a to the power of n. So these are the properties that you need to know. So you can do this in any order you like, really. So here I get the first one, if I have a to the power of m to the power of n, which that's the case here. So the exponent here is 1, 17 to the power of 1. So this would be 17 to the power of 1 times negative 2. So let's take care of that. Okay, so you get 17 to the power of negative 2. And then you have t to the power of, multiply this together. Negative 2 times negative 2, they give you positive 4. You notice that I'm not worried about the negative exponents at this point. And then here get t to the power of negative 3 times negative 2, that give you 6. And then you have 9 over t to the power of minus 4. Okay. There's nothing to multiply here, but I can use this other property to divide them. So here, well, actually, I could multiply this too. T to the power of 6 times t to the power of negative 4. That would be a total of t to the power of, I'm going to add the exponent, 6 minus 4. That would be 2. That would be t to the power of 2. So if I have t to the power of 4 over t to the power of 2, you subtract the exponents now, according to this one. So we use the first three properties. So they give me t to the power of 4 minus 2, which is 2. That goes to the top of the fraction. Now I can move this 17 to the power of minus 2 to the bottom of the fraction and keep the 9 as is. So that would become 17 to the power of positive 2, like we see on the last property. So it looks like we use all these properties to simplify this. So I get 9t to the power of 2 over 17 to the power of 2. And it looks like A is the right choice here. Here we want to find the domain. If you recall, domain is the value of x. So we want to see what are the restrictions we have for x. For what value of x this whole thing going to be undefined. This f of x is going to be undefined. We don't have a restriction for the top of the fraction because I can have a 0 at the top of the fraction. It's still going to be 0. It's a good number. What we don't want is we don't want what we get at the bottom of the fraction would be equal to 0. So you want to make sure that what you have at the bottom of the fraction, 9x squared plus 6x minus 3 cannot be equal to 0, because that would be make this whole f of x undefined. You cannot have anything over 0. So your restriction would be 9x squared plus 6x minus 3 cannot be equal to 0. Pretty much you have to solve for x here. Okay. Can I factor something here? I have 9, 6, and 3. What do we have in common among those three terms, anyone?
3.
3, okay. So if I factor the 3 out here, I can solve for x. So that becomes 3x squared plus, that would be 2x minus 1, cannot be equal to 0. So I can divide both sides of the inequality by 3. So really I'm solving for 3x squared plus 2x minus 1 cannot be equal to 0. In order to solve for x here, I need to factor this. I can use a trial and error method for factoring. Okay, for 3x squared, I can put x and x here. So the only possibility for 3 would be 3x and 1x. For 1, well, there's only one possibility. You're looking for two numbers. When you multiply them together, you get minus 1. So it would be 1 and 1 here. In order to get the right combination and sign for 2x, I can multiply the two closest terms together. That would become x, and two further terms that become 3x. The question is, can I make 2x out of that? Well, yes, if the 3 is positive and minus x is negative here. So that would make this term negative, this term positive. So let's check. The first term, 3x times x is 3x squared, minus 1 times 1 is negative 1. Then I multiply the two closest term and two furthest term together, I get 3x minus 1x, I give you 2x. So everything is here. So now I need to let each of these parentheses not be equal to 0. So the first thing is you want to say 3x minus 1 cannot be equal to 0. X plus 1 cannot be equal to 0. So here if I add 1 to both sides of the inequality, I get 3x cannot be equal to 1. X cannot be equal to divide both sides by 3. So this is one of the restrictions I'm going to show. X cannot be equal to 1/3, and here X cannot be equal to -1. These are the two restrictions we have for the domain of this function. So let's look at the choices we have. X cannot be equal to 1/3. X cannot be equal to -1. So it looks like C is the correct choice here. So here we have to add these fractions, and at the bottom of the fraction, as you can see, we don't have a number, we have expression. So we still have to find the LCD. To find the LCD, I need to factor this. So this will have X in common. So let's go factor that. This becomes X plus 3. And this is just X. This is X plus 3. Can somebody tell me what this LCD here is? What's the least common denominator among those? I'm going to write it right here. What's LCD?
X.
X.
No.
Very good. X times X plus 3. Okay, so you want to make sure that all these three have the same LCD in order to be able to add these. So this is already the same as LCD, but we're missing X plus 3 here for the second one. So I'm going to go ahead and multiply this by X plus 3 over X plus 3. And for the last one, what do I miss for the last one? You're missing X. You multiply this by X over X. So now here it is. This is my LCD. This is LCD. Once you get everything the same as LCD, then you can write this as X times X plus 3. And then now you're allowed to add what you have at the top of the fraction. So at the top of the fraction, you have 6 plus, this would be 8X plus, this is 3 times 8, right? 24. So here would be 8X plus 24. It's like you distributing 8. 8X plus 8 times 3 plus 2X. All right, looks like I can combine like terms. 8X plus 2X, they give me 10X at the top of the fraction. I get 10X. This would be 10X at the top of the fraction. Okay, and we're gonna continue with adding 6 and 24. Is that 30? All right. Looks like at the top of the fraction, I have 10X plus 30. Can I factor this, anyone?
Yes.
Yeah,
Right.
factor 10, right? Let's factor 10. That would be 10 times X plus 3. And at the bottom fraction, we have X times X plus 3. This is where you can reduce. Looks like X plus 3 reduces X plus 3. That turns to 1. So I end up getting 10 over X. So it looks like the correct choice here would be D, 10 over X.